Hey everyone, welcome back to the shop. So we're going to have a little different video this week, meaning I'm going to be doing some voiceover for you. The first part of this video, I think we've got about 16 to 18 minutes worth of video that I did not capture any audio using the camera. I don't know what happened with the audio. I could actually kind of hear it in the background, but for whatever reason, it didn't actually capture it correctly where I could use the audio from the video. So we're going to do a little bit of voiceover for part of this video. And how about we just do a little shop talk, and I'll kind of talk you through what it is that I'm showing you and what we're doing on the machines and my thought process and what we're building here. All right, so let's jump right into it. The previous video, we machined that tap adapter to drive the 1¼ 5 Acme tap, and that's what is laying there on the pig mat. And what I'm showing you is the stock that we're going to be using to make the new nut for the new spindle that I plan on machining for the Hardtail Vise. That is a piece of ductile iron, 2¼ inch, I believe, is what I ordered on that. Got that from McMaster Car, and half of that ductile iron is what we're going to be using to machine the new nut for the spindle there. And what I plan on doing is I'm going to take the long nut for the hardtail, and we're going to modify that. We're going to part the existing threads off of it, and we're going to machine my new nut with the OEM nut where they can screw together, and I won't have to machine that whole new hardtail nut there. This is a print that I made using Fusion 360, something that I could just quickly reference in the shop. Doesn't have all the dimensions on there that we need because I honestly don't know what the threads on the OD of our new nut or the threads that's going to be machined inside the hardtail nut. I don't know what those thread sizes are yet, so I just kind of simulated it there with the drawing. But that's what I'm talking about here is, we're going to be setting that piece up using a steady rest, and we'll part it off. And once we have the new nut finished, we're going to use the new nut as like a thread gauge for our spindle. We'll get our spindle machined, and once that is completed, then we can set this nut that I'm holding back up in the lathe, and we can get it parted off and get the two pieces machined and mated together. And I think that's going to be a pretty fun project there. I decided to go that route just to kind of eliminate all of the material that we're going to have to machine to make that new nut. I just figured if it's strong enough to work like it's designed to now, it should be good enough for me to cut the threads off of it, add our new nut, and go about our business there. And keep in mind, the reason why we're changing the thread is because I wanted to machine a new spindle for the vise. And if I'm going to machine my own spindle, I might as well just make it an Acme thread, which is an American thread, 1¼ 5. That's what we're going to go with. That's the closest size to what that existing spindle is now, which is, I believe it's 30 millimeter. It's a trapezoidal thread, which is very, very similar to an Acme thread. But yeah, we're going to be switching over to an Acme. All right, so here we are at the Precision Matthews lathe. I've got the 3-jaw chuck already set up on the lathe here, so we're just going to use that to get this ductile iron machined. Getting it chucked, making sure that it's running nice and true, but we do have material to machine off of this nut. And what we're going to start with is we're just going to get the outside of the nut cleaned up. We're going to get it round. I believe I turned it to like a nominal size just to kind of make it, something a little more standard. I believe we actually turned it to 3¼ inches. Whenever you order material like this ductile iron, whatever the nominal size is that you get, it's always oversized so that you can actually machine it and clean it up to that size that you order. So if you needed a piece of 3¼ or I'm sorry, in this case, we bought 2¼ you can set this up and you can turn it and you can finish it exactly at 3.25 inches if you want to. But we're just getting it cleaned up here, trying to get it cleaned up nice and round so that we can put a micrometer on it and measure it and get it down to that nominal size that we're looking for. And a couple of reasons why we're leaving it oversized. Okay, so I forgot I did that. So what we're doing is I skint one side round just to get it true, And that is because I plan on taking it out of the lathe and going over to the milling machine, and we're going to mount this up in my Vertex simple spacer, because I plan on milling 3 flats on this nut. Since we've got plenty of material to play with and we're not actually having to machine it down to a finished size, I left it oversized so I can mill 3 flats on it, because the 3-jaw chuck that I plan on holding the nut with will line up on those 3 flats, and it'll prevent any kind of, it'll prevent the nut from spinning in the chuck whenever we go to power tap it with our Acme tap. That was my thinking, my way of trying to avoid any kind of problems down the line. You know, those Acme taps take a lot of pressure to spin. So I think by putting the 3 flats on the outside of the nut to hold it while we're doing our power tapping just made my job easier, not having to worry about it spinning while we power tap it. So we do have that OD now turned down to 2 1/4. And now we're drilling a hole in it. That is a 1-inch drill. We're just gonna, and there's no pilot here. All we did was just center it. So we're pushing that 1-inch drill all the way through there, about 3 to 3 1/4 or so. And then after we drill it, we'll set up a boring bar, and we're gonna bore it to size, which is gonna be 1 inch 55 thousandths. You can kind of consider that like your tap size, but that is going to be your bore size required for an 1 1/4 5 Acme tap, or 1 1/4 5 Acme thread. If you were going to single point it, it would be the same thing. So here we are boring it to size. Just got a boring bar in there with a carbide insert, using my telescoping gauge and micrometer to measure it and get it right there on size. I think we come back in there. Yep, we take one more pass in there just to clean it up. That drill did a good job. I believe it drilled it, you know, somewhere between 3 and 4 thousandths over 1 inch, which is great. So we only had about 50 thousandths to take out. So I usually like splitting my finish passes in 2. So, you know, first one was about 20, second one was about 25 thou. This is my high-speed steel tool bit that I'm using to put a chamfer on here. And what I did was I touched that tool right on the edge, and then I watched my digital readout, and I just fed that tool in 125 thousandths. Cut a nice bevel in there. Now we're going to take it out of the lathe, and we're going over to the KBC mill, chucking it up in our Vertex spacer. This is going to work really good. We got a Walter face mill on there. That's their M4000 face mill, M4000 tool series. Really good job shop series of cutting tools. They all use the same type of insert, so pretty versatile tool. Right there, what I was doing was just checking the out of roundness, you know, seeing how close it was, and it was 3 or 4 thousandths run out, which is really not a big deal. This Vertex spacer, it's an excellent tool, and I absolutely love having that. We use it for so many different jobs. If you do not have one of these for your milling machine, I would highly encourage you to invest in one. It's more convenient to use than a dividing head, and it works great for holding parts, for drilling holes or milling flats. If you got to mill a hex on something, mill something with a square drive, it has a pin that engages every 15 degrees. So if you have something that you can index every 15 degrees, it's just a convenient tool to use, and I just love having it. So there we have our 3 flats machined on the outside of the nut. Now we're going to go back to the Precision Matthews. I was showing off my new Walter parting tool here. This is the first time that I used it for a couple jobs, but this is the first time I showed it on video. And I wanted to use, I had actually got that for the CNC lathe, but it just ended up not working the way I needed it to for the CNC. So I had it in the drawer, kind of forgot about it. And I saw it, I said, well, I want to set this up and use it on the Precision Matthews. And it's a more updated style of insert. It's a better quality insert than some of those older GTN style. So it did a really good job. Put a catcher rod in the chuck for the tailstock, and it'll catch your workpiece just like that there. And there you have it. Well, so what we'll do is we'll go ahead and set it back up in the 3-jaw and clean up that parted side. We'll get it faced, get it chamfered, get it faced to the proper length. I was shooting for a 3-inch length there. Usually when I part something off, you know, you'll add about 30 to 60 thousandths to give yourself enough room to clean it up. So we got a facing tool there. We're just going to face it off, get it nice and clean, make it look like a nice uniform piece. Checking the length. Looks like it was about 3 inches 2 thousandths. Chamfer the OD, and we'll put our high-speed tool back in there and chamfer the ID. Same thing. Once you touch the corner, go in 125 thousandths just to make them uniform, really. So now the nut is finished up, the first stage of it anyway. We are ready to take it to the home shop so that we can use our big Flexarm GH60 with our new Acme tap and hopefully have a successful power tap operation. Okay, we made it back to the home shop, so we're going to use our big hydraulic GH60 Flexarm here to get this job done. First task though is we're going to mount this new 3-jaw. So this is a 6-inch Bison 3-jaw chuck that I got from KBC Tools, and I got it specifically to use for things like this. What I had planned to do is machine a fixture plate to bolt it to, which I'm still going to do. We're going to have a fixture plate where if we want to, we can just set it right here in the mill, this mill vise. This is what I usually use. So we can take it, put it in there, clamp it quickly if we have shorter pieces. But in this case, I wanted to get the chuck down closer to the table because we have a long tandem tap that we're going to be driving. So we're going to mount it right here. And if you look, these are the 2 mounting holes for that big 8-inch vise there. So we're going to mount the chuck in this square. So when the vise is over here, this is going to be covering up these holes. I didn't want this out here to have extra holes out here in the work area. And I didn't want it over here that's going to be on top of the hydraulic power unit. So somewhere right in here is what we're going to do. So we'll get it clamped, transfer those 3 holes. We are going to drill a clearance hole in the center there as well using a pretty good sized drill just to provide clearance so that when we're tapping with these tandem taps, we can go all the way through. When you're using those Acme tandem taps, you're not supposed to reverse them. You're supposed to go all the way through the part as far as you can go and drop it down the bottom. So that's what the plan is there. Here's our nut that we just finished machining, our 3 flats, and now you can see what I'm talking about. We can, whenever we go to tap this, we'll be able to tighten it up in that 3-jaw, and the 3 flats will prevent it from spinning. Hopefully, that's the plan anyway. All right, this is the chuck key that came with it right here, and it did come with the 3 bolts that we can use to bolt it down. So we'll get a mag drill set up and go ahead and get this knocked out first. All right, so this is about where I want it. I'm just kind of looking at it, making sure this jaw is lined up, square with the world. Transfer these 3 holes, but I also want to transfer the center hole there as well. So let me show you how I'm going to do that. Got this piece of 1x2 DOM tubing. We're going to go ahead and drop that in there. Snug that up. And I think that's where I want it right there. That should be good. Take our C-clamp and go ahead and clamp the chuck in place. All right, 1-inch transfer punch. Actually, I lied. It's not 1 inch because 1 inch wouldn't fit in there. So this is a 63/64 transfer punch that I have, and it's never been hit before until now. So that'll be that hole in the center. And now we got this transfer punch that fits these holes here. And that should be transferred, just seeing that it didn't snap it off there. These transfer punches, I was always taught to hit it 1 time. And then if you need to open up the punch mark, then you come back with a centering punch and hit it again, which is what we'll probably do. Left this cardboard here so I'm not sliding that around and scratching up the bottom face of that chuck there. All right, so I can see that one. Let me go get my, I like to draw a little circle around them so I can see where they're at. I seem to have lost my yellow Dicom marker. So we'll use this red one. Maybe we'll use it. Let's see if we can get some paint out of this thing. Looking in the wrong place. Here's the center. There's the center hole. Come on, man. These things seem like they take forever to get the paint down there to them, don't they? I think it's time to replace it. It's not wanting to work there, so we'll just go around these one more time. I ended up finding the white one. Let's see if this one will work. These things, I have a love-hate relationship with these stupid pins here. I mean, when you need one, they're excellent, but if you don't use it every day, they just seem to sit there and they go bad and they dry up. So now how about a little bit of a paint color there? Will that work? Now we can at least see where we got to go. And now we can go ahead and use our center punch here. I'm going to use our new Walter mag drill for this. What I really like about this mag drill is that it's got forward and reverse, and you've got 2 speed ranges on here, and then you have a variable speed drive up here at the top, or you got a selector so you can adjust the speed that you want to run. All right, so we've got a center point in the chuck, and I've already got it centered up on that first one. So we'll go ahead and get our drill in there. So I'm just going to drill it. We're going to drill it, chamfer it, and I'll just use the Flexarm to tap it. This is an old chuck that I'm using. Even though it's a good chuck, it probably won't hold a tap very well, and it's just going to spin in it. So might as well just use the Flexarm to put the holes in there. Now this guard on here is designed so that you can, you know, everything's designed with safety in mind now, right? You guys obviously want to see the cut. I want to see the cut, but you can take this guy and just slide it down like that. And do your drilling, and it's gonna, right underneath the table it goes. So that's just gonna guard the chips from slinging around and hitting you, just if you guys are interested in that. All right, got a push button start in the back. These things are a little noisy, especially for me, so I'm gonna be using my earplugs for this. But we'll go ahead and speed it up a little. That's max speed right there. CRC cutting oil. Well, that did not go as planned. I did not expect that to happen right there. I was really pulling hard on that drill. But I don't know why. There's no reason it should have broke though. I wasn't even hardly in there and it snapped off. Huh. Wow. All right, well, now I got to back up and redo everything that I just did, because now we have a broken drill inside of a hole. That's a pretty rare thing that's happened to me, is a drill actually breaking. So that shouldn't have happened. I've used these drill bits many times. I've got several of them in there I've drilled hard on, but why that thing snapped off, I don't know. I guess it wasn't wanting to cut and I was just really hammering on it. I'm gonna go ahead and back up. I'm gonna have to grind this drill. It gets stuck down in there and that'll slice your finger right open. So I'm gonna just dress this off, and I'm gonna set the chuck back up here and go ahead and transfer punch it again, just index it a little bit. And then once I have that done, we'll come back and maybe we'll get a hole drilled and tapped here. Okay, I have repunched all the holes. We're ready to start drilling again. 5/16 jobber drill. This is just a standard jobber grind right here. I'm going to use a chamfering tool here to cut a chamfer on that hole. Okay, finally, we got one hole down. 3 more to go. We've got our 3 5/16 holes drilled there, so now all I got left is the center. What we'll do is we'll spot it. We got a 1/2 inch drill, and then this is a 1 3/8 drill right here that we're going to use to drill a 1 3/8 hole in the center. So this is gonna put the drill to a test. Hopefully it's gonna be able to drive that drill. So let's see if we can make it happen. I retract that first statement. This is the problem that I ran into the last time that I used this mag drill. So it's all the way up as far as it goes. You can't adjust it any higher, and a 1/2 inch jobber drill, you can't fit in there. Now obviously you can move this over and stick it up in there, but then you lose your center point that you lined up on. Same thing with the 1 3/8 drill. I can't get it in there, can't get it in the chuck. So that is really frustrating and annoying right there. So I think I'm gonna have to put the ice cut away and just bring out the trusty Bucks, because I know it'll get the job done. I brought out Dad's Bucks mag drill to go ahead and get this center hole drilled. I'm gonna spot it, and then we'll drill it with a 1/2 inch drill to create a pilot through there. And then I've got this 1 3/8 reduced shank drill that we're gonna use to put the hole in there, hopefully. One of the reasons why I like having a newer modern mag drill, one of the benefits on why I got one was because of the variable speed motor that's on there. The Bucks, this is a fantastic mag drill, super heavy duty, robust. It always has worked great, but it's a 1-speed motor and it runs at 650 RPM, which is way too fast for these big drills. That's why you'll see me, and you've seen me do it in many videos, when you're drilling, you're just toggling this switch on and off to reduce the speed, you know, and you kind of let it idle down, slow down, and you hit the switch again. So that's what I'm going to be doing with this large drill here, and keep it lubricated with some oil. But that's why I wanted to use the Walters, because you can slow that sucker down and run it at the proper speed for drilling ops like that. So we'll see if the Bucks can get it done. It usually does a good job, and hopefully it's not going to let me down. It would help if you tighten the chuck. That was a little nerve-wracking right there, but we finally got it. That's the biggest drill that I can remember drilling with the Bucks. And one thing that I didn't take into consideration was, you know, the torque that it was going to need to push that drill. So as you applied some pressure to the drill there, it was obviously slowing the motor down, and I felt like I had it in a pretty good spot. on speed and pressure. I could tell that if you pull too hard, it was going to try to stall the motor, which I didn't want to do. So I think we kind of found a sweet spot, if you will, that worked good for the drill. So we got her done. We got her done, and I don't think I burned the drill up either. Yeah, that drill still looks nice and sharp. Oh yeah, it's still good. We had used this drill on the lathe not too long ago. I had showed this. This is the one that I mentioned I found a few in an antique shop here locally, and I paid 10 bucks a piece for these things. And I don't know if you can see it on that GoPro video, but it still looks good to me. I was worried that it was going to burn it up. YG, that's the brand of that one right there. It's probably a cobalt drill. But anyway, it did good. All right, so I just need to do some deburring on that hole, get rid of that burr on the bottom side there as well, and we'll get our chuck mounted. All right, we'll go ahead and get the holes tapped. We got a 3/8/16 gun tap in here. All right, I think we're ready to roll. Every time I wipe that off, I get another piece of grit on my hand there. All right, let's see, how did we have it? We had it oriented that way. All right, there we go. That should be it. Hopefully that's going to work good. So now that we got the chuck bolted down, I wanted to be sure that the spindle of the Flexarm was perfectly aligned with the chuck. Make sure we're going nice and straight. So what this is a magnet that you use to square up to your work surface. And that's exactly what we've done. I've already got it stuck down on there, and I'm not seeing any gaps, so it's not, you know, tilted one way or the other. So it should be good. It should be aligned. Putting the jaws back in there, so they got them stamped 1, 2, and 3, and your jaws will also be stamped 1, 2, and 3. So I just look for the start of the thread on the scroll and get it started. Watch it coming around to number 2. There's the start of the thread. So we'll take our jaw number 2, get it started. Watch it on number 3. There's the start. And number 3. So if you've ever wondered how you line up your chuck jaws in a 3-jaw or 6-jaw or self-centering chuck, that's how you do it. Well, that's a good feeling chuck too. It's not too tight, and you can see it comes right to the center there. If you ever get them in there the wrong way, you'll know instantly, because these guys will not be in the center. They'll be off a little bit. I think it is just about time to get our Acme tap set up and attempt cutting some Acme thread. All right, so here is our nut. Remember, we got our 3 flats on there. Line the flats up with the chuck jaws. All right, close fit in that thing. All right, so there's our tap driver, our tap adapter. And now we can go in with our Acme tap. This thing is pretty sharp, that's why I'm putting a rag on it there. Let's see. Just adjusting these set screws to where they're just touching. Okay. There it is. A little nervous about this, but we're going to go for it and see if we can do it, right? I'm getting the RPM set. I've got it set at 15. I want to take it nice and slow, and I think that's the proper speed to do something like this. That's 15 right there. Just going to take it nice and slow, and we're going to go all the way through this. Once we get all the way through, I should be able to release the tap and then screw it by hand, even with a tap wrench. We can come out the bottom side there. I think we're going to use that right there. 15 RPM and gear selection 1. So for the tapping, I am going to use my anchor lube for this. It's generally known that you don't have to use any kind of cutting fluid or coolant whenever you're machining ductile iron or cast iron. But I have found that when you use anchor lube for tapping cast iron or ductile, it just works better and it creates a better quality looking thread in there. I want all the help I can get because there's a lot of tool pressure that's going to be applied to this tap. So anchor lube for us for this job here. I'm just going to go ahead and brush it on there on all the flutes. I have especially found it beneficial whenever you're tapping with pipe taps, when you use anchor lube and tapping in cast iron with pipe taps, MPT. Let's start with that, and then we'll see how it's going to do, and then we'll brush some more up on. So we didn't talk about the tap. You guys might be wondering, this is considered a tandem tap, and a lot of the Acme taps you'll find like this. The first section here is ground so that it kind of roughs the thread out, and then this top section here is what finishes it to size. So you have a roughing and finishing section there. I'm going to go ahead and put a little bit down inside the bore here as well. Let me see, I think I got a small acid brush that'll reach in there. Yeah. Don't be stingy with it. Get plenty in there, and hopefully that's gonna work well. All right, here we go. All right, so far so good. We got the roughing section in there now, so we'll go ahead and put some more anchor lube on the finishing section of the tap. All right, I think we're ready. There it is, success. Well, I got to say that was relatively uneventful. No problems there. It didn't sound like the tap or the machine was any kind of like major load. So I feel confident now that we've done one of these that it'll pretty easily handle this job in the ductile iron. Now this is a different story if you're trying to tap some steel, even mild steel, or even chromoly type steel. I don't know if it'll handle it, but this softer, short chipping material like this ductile iron worked really well. I think our plan came together nicely. Our 3-jaw, our flats, to ensure that we weren't going to spin. I did that purposely so that we wouldn't have that kind of problem. I didn't want to get the tap all the way down in there and all of a sudden the parts start spinning and no way to really complete the job there. So the flats worked out good. And our threads look beautiful on that side there. I need to get it cleaned well. They look really good. I'll go ahead and get it washed out. See if the screw that I bought, some commercially available Acme rod, we'll see if it screws on there. All right, well, we've got the nut cleaned out, got it blown out real good, got all the chips out. It looks good. Got a little bit of a burr right there I need to flap, but the thread itself looks really nice. It looks like what you would expect to see when you're using a brand new tap, cut through some material. It looks really good. Our tap did really well. I got it cleaned off, ready to put away, and it did a good job. I've used a few different Acme taps throughout my career, never one this big. 3/4 a few times. I think I've used a 7/8 and a 1-inch. And there was one job we did. We had to go through some kind of bronze material, and it was, I don't remember what kind of bronze it was. It was pretty tough. And I remember using this tap, one like this, and every time you would go to twist it, you would hear it squeaking and squealing. You would physically see it trying to twist, and I was just really worried it was going to snap it off. No problems with this material here though, the ductile iron. I never saw it under any kind of like heavy stress or load, so I think it worked out really well. So happy with the performance of the tap here that we got from KBC Tools. So the nut looks good. Here is the Acme rod, just a piece of commercially available Acme rod. And it's screwed on there just like it should. Just like it was made for it right there. You have a very, very slight amount of clearance inside there, and nothing that feels out of the normal. It feels just like it's supposed to. You have your diametrical clearances on there so it doesn't bind up. And I just think we have a really good fit on that screw. All right. Well, this part of the job is finished up here. We're not through with the nut yet, but I think from this stage, the next phase is to go ahead and we need to set up the big nut that this is going to be screwed onto, and we're going to modify it. We're going to finish modifying the outside. We're going to have some threads turned on here. We're going to bore some internal threads on the large nut and have this thing where it all screws together. So that should be the next phase of the build there. All right, I'm going to finish getting our work table here cleaned up, and I will see you guys back at the new shop so we can get this nut finished up for the Hardtail Vise.